In this video we talk about the line or the equation of the line as far as what it represents on the Cartesian coordinate plane. So the points on a line, and there are infinitely many of them, but we're not going to graph all of them. The points on a line are solutions to the equation for that line. So if we take a look at something like y equals 6x, any point on that line y equals 6x will solve or will be a solution, will make that equation true for that line. Now, one of the tools that we have is more of an organizational tool than anything. There was always a couple things that bothered me in my math classes, and there were two main things. But the first one was something that Einstein apparently was famous for, and I'm sure that there are plenty of professors and teachers out there who go, oh, well, it is easy to see that, or it's obviously clear, or it's obvious that. It's never obvious, it's never clear, and it's not easy. So if I ever say that, immediately in the comments go, that's crap. Anywho, it will feel easier later. The second thing that scared me the most was choose, because invariably there was some kind of a trick to it or a hint as to what you were supposed to choose. And here I'm going to tell you that there are choices that will make your life easier. It takes a lot of thought and a lot of experience to be able to see those choices easily. So by and large, they tell you, okay, well, pick x values of -1, 0, and 1, and then that will find your line. Okay, you only need two. It's 2 points that determine, 2 unique points determine a line. So the third one is a check. That's the reason they tell you to do it. So we're just going to go ahead and we're going to find 3 points, and hopefully they all agree and are called collinear, meaning that they all fall on the same line. If they don't, stop. You did something wrong. I'm going to set up something called a t-table. It is called that simply because it looks like a T, and it forms a table. The fun part about this is that as I move through this t-table, the entries that I create are actually points on the line. Again, assuming I did my math right. Okay, so we need some points on this line. We got to make some guesses. So I am going to guess that x is 0. And basically what I'm saying is I'm going to make x 0, and then I'm going to see what y has to be in order to make this equation true. So to do that, I take my 0, I plug it in for x because that's the variable I chose. So y is going to equal to 6 times 0. Well, 6 times 0 is just 0, so y is equal to 0. So I just throw a 0 in there. And that becomes a solution to this equation, which also makes it a point on the line. So we just throw it on the graph. All right, let's get a couple more. So we now have, I don't know, what do you want to put in there? Just make it up. Now, I do know that there are some limitations on my graph because I only go from -8 to 8 on the y and -8 to 8 on the x. So I'm going to choose small numbers of x because I'm going to multiply them by 6. I'm going to choose easy numbers though. So I'm going to choose 1 to be x. And then when I do that, let's take a look at what happens. Well, then I say y is equal to 6 times 1, which is just y equals 6. Okay, so I take a 6 and I plug it in there, and then I make a point. So now 1, 6 is another point on my line. So over 1, up 6, right about there-ish. When you have grid points or grid lines on your graphs, it's way easier to graph. Here I'm just kind of like mehing my way through it. All right, let's take a look at another one. I am going to allow, and I'm doing this because I know what's coming. So don't think that you have to choose like this. You can actually choose another value of x. I am going to choose -6 for y. I'm doing this to show you you don't always have to choose values of x. All you have to do, excuse me, Thank you. All you have to do is choose a value for one of them and find the corresponding value. Okay, so we're starting to encroach in a little bit in here, but we're going to plug -6 in for y, and then we're going to go 6 times x. We don't need the parentheses. So to solve for x, then, we just divide both sides by 6. That's going to give us -1 is equal to x. Okay, so just stick a -1 in there. And then you can go back and check it. Does -6 equal 6 times -1? Well, sure. Then that is a point on our line. -1, -6. Right about there. Okay, so now, if I did it right, what I should be able to do is to start at one end and draw a nice straight line, or that. I draw a nice straight line. Come on, man. Can you do it? There you go. A nice straight line that should pass through all 3 of my points. And it looks pretty good. If I didn't palsy out on that last one there. But this looks pretty good. So we stick little arrows on the ends to say, okay, that's going to continue in that direction forever. It's a line. How many points are on that line? An infinite number. So it just keeps on trucking. All right, we're going to do the same thing for this green one down here. I'm going to move down slightly. There. All we have to do is create our t-table. And then we just go ahead and label our x and y. Notice I'm putting them in an ordered pair format. The x first, then the y. It keeps my brain from mixing them up. Okay, I want to choose a value of one of the variables. So a hint. This particular form is known as Slope-Intercept Form. The easiest way to generate solutions out of this form, not by far, but usually pretty much, choose values of x and then find y. If you choose values of y, you got a lot of solutions, there are a lot of steps to solve it, that sort of thing. So it's usually easier just to go ahead and choose values of x. So we're going to choose the values. We can't choose -1 because I don't have enough room. So let's choose the value 0. So if I plug a 0 in for x, that means I get y is equal to 4 times 0 minus 7, which is really just 4 times 0 is 0, minus 7 is -7. The other 7, that kind of looks like a 7, not a 1. That's one of my points. So 0, -7. Change that to green. Plop a point right there. Now these two graphs are not going to intersect, which is good because that would make a mess. Now I can't choose -1 because -1 times 4 is -4, minus 7 is -11, and I don't have enough space on my graph. So I'm going to go ahead and choose 1. And then I'm going to find out what my y value is. So I have 4 times 1 minus 7. 4 times 1 is 4, minus 7 is -3, so y is -3. Then we would just go ahead and plot that point over here. +1 on the y, or x, -3 on the y. Yeah, it's right about there. Of course, I didn't change it to green because why not? So we plop a point right there. And then finally, I'm just going to choose 2. I'm just going to keep going up. It seems to be okay if I just continue to move up in the x's. So that's going to give me, in white here, y is equal to 4 times 2 minus 7. Get into the habit of putting parentheses around the value of your variable. I can't stress that enough. As you move on, when you make substitutions, you will have other numbers, or you might make substitutions with letters. When you make a substitution, it's the whole thing that gets substituted. So 4 times 2 is 8, minus 7 is a +1. So y is 1. So go back to green, and we have 2, 1. My dog is snoring. Oh wow, okay, that's why it doesn't look right. My apparently I'm a little off center of my screen, and my 1, -3 didn't look right. 1, -3 should be over here slightly. There we go. So now we connect the dots. So I'll start at -7 and move upward through these. Oh, again, a little bit of a jerking motion there. Kind of got it off kilter. Wow, that is terrible. Come on. I hold shift, you draw a straight line. Thank you. So it looks about like that. Again, arrows at both ends to signify that it moves in that direction forever and ever and ever. These two lines eventually will intersect. That's a whole nother ball of wax. So if you want to know why that happens or how that happens or how to find when that happens, look at systems of equations. Other than that, this is graphing a line. All you got to do is find points on the line, draw the point, or put the points on the graph, and then draw a line through the points and sing the song. Hope this helps.